We're going to do number 9 in this video, and we're given an average cost function. Some of the other problems, like the earlier video, we're given the cost function. So in this problem, for part A, we're doing the reversed. We're given average cost. What's our formula for total cost? So remember, average cost is total cost divided by Q. So this tells us average cost times Q is going to be our total cost. So our total cost, just multiply all of this by Q, and we're going to get 0.01 Q cubed minus 0.6 Q squared plus 13Q. For part B, we're asked to find what is the minimum marginal cost. So in this chapter, we are asked about finding max and mins of lots of different things. We want to minimize cost, we want to maximize profit, we might maximize revenue. We have to really be careful. We want to minimize marginal cost. So what we want to do is we want to first find what marginal cost is. And remember, that's the derivative of cost. So we're going to get the marginal cost is going to be 0.03 Q squared minus 1.2 Q plus 13. And since this is what we want to find the minimum of, we need to take the derivative of that again. And we take this and we get 0.06 Q minus 1.2. And in order to find the critical point, we want to set the derivative of what we're trying to minimize equal to 0. And we get, this happens when, so we have a critical point of marginal cost when Q equals 1.2 over 0.06 or 20. So then the question is does this actually give a minimum? Well, a nice way to think about this is if we look at our marginal cost, this is a parabola opening upward. And what we just found was the first coordinate of the vertex. So we do, this is a location of the min of marginal cost. So when we go back to the question of part B, it's asking us what is the minimum of a marginal cost. So the minimum marginal cost, we have to plug in 20 into our marginal cost. And plugging it in there, we get $1. $1. What is that? $1 per item. That's what the units are on marginal cost. So that tells us this is the smallest marginal cost we can have. For any production level, our marginal cost is smallest at this production level, and that's the smallest marginal cost we'll have. So our cost function, right, the slopes of our cost functions will always be positive, and the smallest positive slope we see would be slope when the slope of it is 1. All right, now we're at part C, and we're asked to minimize average cost. And so since we're given our average cost function, we might as well find the derivative of average cost, and we get 0.02Q minus 0.6. And we're going to set that equal to 0 to find our critical points. And in this case, we get, I'm not going to show the algebra, but we get Q equals 30. And going back to, does this, this is a critical point, going back to the idea, well, does the critical point actually give us a minimum that we want? We go back to our average cost, what we're trying to minimize, and we see that it's a parabola opening upward. So what we just found was the location of the vertex of that parabola, if we were to graph average cost. So this is the location of the minimum of our average cost. So that is our production level. So that's the answer for the first part. Q equals 30 is when we produce 30 items. Average cost is a minimum. And then we ask, what is that average cost? And when we plug this in, plug 30 into here, I'm not going to show writing it down, do the calculations, you get 4. That means the average is $4. Average cost is $4 per item. Right? It could have been, the actual cost of making the first 10 was more than the last 20 because we were able to get bulk pricing. But when we look at it all, producing all 30, we got $4 per item. Now for part D, they asked to find marginal cost of 30. And when we plug this in, what are we looking at? We're looking at marginal cost. Plug 30 into this formula. We also get 4. Which, if we go back to our fact before, that we have a critical number for average cost when marginal cost equals average cost. We just showed that. This is the same. So this is $4 per item. So marginal cost equals average cost at the spot when average cost is minimized. That's a nice fact about average cost and marginal cost.